only your marks, but if you're not satisfied your marks, so maybe after the class, so you can maybe you can okay, you can ask me why you get like this. Okay. Okay, so let's start our class. Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all of you. Alright, so today we go for the another topic is simple neural networks. Alright, so simple neural network is the primitive neural network lah. Okay, such as McCulloch-Pitts, okay, Herb's learning algorithms, the Perceptron, Adeline, Medellin, Fukushima. Right, so this is a techniques. Okay, there is a technique is in the simple neural network lah. So this one is the primitive. We call it primitive neural networks. Right. So today we just cover on the some issue on the neural networks. There is a bias and threshold, and then we go for the simple neural network lah. Okay. Right. So the objective of this topic will be by understanding the limitation of primitive neural networks. Okay, primitive neural network that I mentioned to you is the simple neural network lah. Is the early stage of the neural network. So can provide us the new insight of new neural network paradigm lah. So this module will allow the student to understand several primitive neural networks. Okay, such as that I mentioned to you is the McCulloch-Pitts, alright, Herb's neural networks, perceptrons, Adeline, Medellin, and also the Fukushima lah, and how they are used to solve the simple pattern classification problems. Okay, and also to study some of the important early development in neural network lah. So actually the simple neural network is the early development of the neural network lah. That's why we call the simple neural network. That means involve of simple mathematicals on the simple neural networks. Okay, and then to be able to understand how they have been used in the pattern classification. Okay, and last but not least is to see their limitations and the need for the better models and learning algorithm lah. Okay, because of this is a simple neural networks, we have a lot of limitation. Okay, for the every technique such as a McCulloch, okay, Herb's, Perceptron, and so on lah. That's why we need for better models and learning algorithm lah. So nowadays they go for the better model and go for advanced, okay, advanced algorithm lah on the neural networks. Okay. Right. So there is general information of the neural networks. Okay. First is the bias. Second is the threshold lah. Right. So we go one by one. What is the bias and what is the threshold? All right. Okay, so the bias, actually the bias is at exactly like a weight lah. Okay, as you remember, so actually this is, sorry, all right. So actually this is our, for example, this is our neural networks. Okay, okay, this is we call the net inputs. Okay, network inputs, and then this is output. And then for example, this is input 1, input 2, input 3. So as you remember on the neural network, they have the weight. they have a weights for every inputs. We declare as the W1, okay, W2. This one is the W3, and then okay, so they mentioned this one is the bias at exactly like a weight lah. So this one so normally we have another one here lah. We call the bias. Okay, we call the bias, and it is considered as the connection, and its activation function is always 1. B equals to 1. Okay, so the activation function is 1 for bias. Okay, so it then adaptively similar like weights. Okay, that means our bias also will be adapt like weights. Okay, this one weight 1, weight 2 will be similar. Our bias will be adapted lah. Okay, according to the learning rule of the neural networks. Okay, the function of the bias is to increase signal levels in the neural network, such as to improve the convergence lah. Alright, so some of the neural network they use any bias lah. Okay, depends on the neural network. So some of the neural network they use the bias here. Some of the network they don't use any bias signal lah. Alright, so this one will be similar lah. Okay, for example, if this one we call the net input is the S, we declare as the S here. Alright, so the formula of S equals to summation of Xi Wi. Okay, for example, this one will be X1 multiplied by W1 plus X2 multiplied by W2 plus X3 multiplied by W3. Okay, this one not involved of bias, but if we have the bias, just plus bias. Okay, this one or sometimes we can write like this: S equals to B, okay, plus summation of Xi Wi lah. Okay, this one Xi depends on the how many inputs and also how many weights here lah. So normally on every input they have the weights. Okay, they have the weights. Right, so this is a standard formula. Standard formula to calculate the net inputs. This one we call the net inputs lah on this neuron on this processing unit lah. But S is not the outputs. Okay, the Y is the outputs. Okay, Y is the output, but S is not the output. S we call as the net input, or sometimes we call the networks inputs. Okay, that means we will collect all the information from the inputs. Okay, that means multiplication of the inputs and plus the bias. Okay, that is we call the S here. Okay, this is formula for S lah. Right. Okay, this one okay, this one formula is the standard formula lah. Okay, S equals to B plus summation of Xi Wi lah. Alright, so for example, okay, we have the X1 equals to 1, X2 equals to 0 lah, for example. Weight 1 equal to 1, weight 2 equals to 1. Okay, so bias will be 1 lah. So we can calculate the S. S equals to 1 plus, okay, summation of X1 is 1, okay, multiplied by W1. Okay, this one X1, W1, okay, plus X2 will be 0, W2 will be X2, W2. Okay, so the answer will be 2. Okay, so the answer will be 2 for the S here. For the S here, so S is not the output. S is not the output lah. Okay, S is this one output on this part lah. Okay, output on this part lah. On this part this we call the S lah. So net inputs. Okay, so S equals to 2, for example. So if we have another input, just plus. For example, we have X3. So just plus another inputs lah. For example, we have the X3 multiplied by W3 and so on lah. If you have 10, so you have to add another inputs multiplied by weights. Okay, that is the standard formula. Standard formula for all simple neural network lah. Okay, that means if you use the herbs, okay, you use the perceptron. Also, starting you have to calculate this one. We have to calculate the net input lah. Sometimes we call the net inputs lah. Alright. So that is the standard formula for calculate the all, okay, S okay, net input for the McCulloch-Pitts, herbs, okay, perceptron, Adeline, Medalline, and so on. Alright. So next we go for threshold. Okay, next we go for threshold. So the threshold is the value that is used to make some form of decision in the neural network, such as the neural network will be fire or unfire. Okay, that means or 1 or 0, yes or no, and so on lah. Okay, so it quite similar to the bias but not adapt. Okay, so the threshold is not adapt. Okay, this is some example, the example of threshold. All right, so we set as threshold equals to, for example, we set as the 2 lah. Okay, I set threshold equal to 2. Okay, from the previous example. All right, so I just give another example here. Okay, this one we have the bias x1. Okay, x1 w1. Okay, x2 w2. Okay, maybe we have another one x3. Okay, w3. Okay, for example, x1 will be 1, 1, 1, and this one will be 1, 0, 1. Okay, and then we get the s here, and then we get the y lah, output. So the first step that I mentioned to you, first we have to calculate the net input lah, the s. Okay, s using this formula, b plus summation of xi wi. Okay, that means 1 plus, okay, with 1, okay, x1 multiplied by w1 plus x2 w2 0, okay, plus another one, okay, x3 will be 1, y3 will be 1. So the total is 1, 2, 3. All right, s equals to 3. Okay, s equal to 3. That means if we set the threshold is 2, that means our input will be here. Okay, our input will be here. So automatically our output will be 1. Okay, that is our output. Okay, output will be y. Y equals to 1 because of the threshold. The threshold equals to 2. That means our s greater than threshold or equal than threshold. That means our input, our output will be 1. Okay, if less than threshold, that means maybe 1. Okay, maybe 1 or maybe 1 or some 1 point something. So the output will be 0 lah. Okay, here maybe our this one our s calculate here, we get here 1 lah. For example, s equal to 1. So automatically our output will be y equals to 0. Okay, so maybe we go for another example. Another example here. Okay, so simple example. Okay, this one x1, x2, x3, x4. Okay, so I put as the 1, 1, 1, 1. Okay, this one weight weight 1 I set as the 1, 0, 1, 0. Okay, the bias set as the 1. Okay, and then I'll set the thresholds equals to 4. Okay, equals to 4. Right, so we have to calculate the output. What is the y? Y equals to what? 0 or 1. Okay, so the first step we have to calculate the net input lah, the s. S equals to plus minus summation of xi wi lah. Okay, so b, okay, b is 1 plus, okay, 1. Okay, just multiply x1 multiply by w1 okay, plus 0. Okay, x2 0, this one plus 1. Okay, this one plus 0. Okay, so the total will be 1, 2, 3. Okay, so 3. That means our s less than threshold. Less than threshold. That means our output will be 0. Okay, so our output will be 0. Okay, that is the function of threshold lah. Okay, that is function of threshold. Okay, so if you can see if net input less than threshold, so automatically our output will be 0. If, for example, I calculate this one, we get 4. Okay, we get 4 here. For example, we get 4 here. So s equals or greater than threshold, y equals to 1. Our output will be 1. Okay, so similar like this lah. So for example, we set this one threshold equals to 4. So is, for example, like this one, our will be 4 here. So automatically our output will be 1 lah. If greater than 4 will be 1 lah. If less than 4, okay, so totally we know the y equals to 0. Okay, that is the function of the threshold lah to neural network will be fire or unfire lah. Okay, to be 0 or 1 or yes or no lah. So that is a function of threshold lah. Okay, so next we go for the simple neural networks. Okay, there is some introduction lah. Okay, normally that called as the primitive that I mentioned to you is the primitive neural network lah. It is the early stage of the neural network. That's why we call the primitive lah. Now more advanced of technique inside the neural network. Some with that we call maybe backpropagation. We have the SORM technique and so on lah. Okay, so and then second mainly used as the pattern classifier. All right. So before this, the simple network they use the some example just use the, for example, detect the abnormality of hearts. Okay, heartbeats, for example, and then maybe pattern classification. Okay, or maybe can use for cancellation of echo in the telephone line. All right. Okay, so usually single layer architecture lah. Okay, single layer. Okay, that means they have only single layer lah. Okay, they have inputs and outputs. Okay, this one no hidden layer. No hidden layer. For the simple network, they have that I mentioned to you before this. The neural network actually they have the inputs. Okay, and this is what we call the input, and then we have another layer here. We call the hidden layer. Hidden layer for second layer. And then last layer, third layer, fourth layer, we got the third layer we can declare as the output lah. Okay, for example like this. Okay, these are example of the latest neural network lah. Okay, for example like this. Okay, and then this is for output lah. This one for input. Okay, but for the simple neural network, there's only the single layer lah. That means they have the input and outputs. Okay. So that is for simple neural network. Don't have the hidden layer. Alright. So use in the 40 something to 60 something for simple application that mentioned to you. Some such as detect abnormality of the heartbeats. Okay. Sometimes detect the membership in the class. Okay. Either in or not. Okay. That means maybe yes or no, 1 or 0 lah. Okay. Something like this lah. Okay. You can see this one. Yes or no. For example, this is input pattern, and then the output will be yes or no. Okay, depends on the input pattern lah. For example, for this some example lah, we have anomaly to detect the abnormality of the heartbeat heart. Okay, for example, they use the simple neural network. Okay, they have 46. They have 46 input. They have 46 inputs. Okay, maybe every this one they have the weight lah. Okay, for every input they have weights, and also you can set as the bias here, and y equals to normal or abnormal. Alright, that's mean only 1 or 0 lah. Maybe we can declare as 1 is the normal or 0 is the abnormal. Alright, the output will be normal or abnormal. Okay, there is some example lah, some example application. Okay, they use the simple neural network lah. They have 46. Okay, 46 input, and then the output only 1, either normal or abnormal, or yes or no lah. Okay, right. So this is several example of that I mentioned to you. It's a primitive neural networks. Okay, such as McCulloch-Pitts. Okay, McCulloch-Pitts. You can see this one. The first artificial neural lah. That's why we call them McCulloch-Pitts lah. The founder of this technique is the McCulloch-Pitts. Okay, McCulloch-Pitts. They introduced the first artificial neuron lah, something like this. Okay, this is founded by McCulloch-Pitts lah. Okay, McCulloch-Pitts. After this, we go for one by one lah. And then for the herbs, okay, for the herb, will be introduced the first implementation of learning neural networks. Okay, that means will be adapt our. Okay, this one, for example, week 1, week 2, week 3. Okay, so every week we have here. Okay, we have week 2, week 3. So on the McCulloch, they don't have adaptation of the weight. Okay, for the McCulloch, only for similar like before this, just multiply inputs multiply by weights. Okay, and then total up, you can get the output lah. But for the herbs, okay, they have the adaptation of the weights. Okay, that means every weight will be adapt. Okay, will be adapt for the next iteration, So the weight will be changed lah. Right. That is on the Herbs learning, and then we have the Perceptron, okay, Perceptron, and then they have the Madeline, Adeline, okay, and then last is the Fukushima lah, okay, Fukushima. So you can see this one that I mentioned to you. All right, so some example of this simple neural network, okay, the detect of okay, abnormality, heart abnormalities, okay, with ECG data as the input. Okay, you can see 46. Okay, they have the 46 input measurement, and then the output will either just normal or abnormal lah. And then second is the echo cancellation in the telephone lines. Okay, and then last is the they use for pattern classification lah. Pattern classification. This some example of application using the simple neural networks. Okay. Okay, so next we go one by one for the simple neural network. The first is the McCulloch-Pitts neuron. So that I mentioned to you, they introduced the first neuron. So for the McCulloch-Pitts, use only binary activation signal lah. Okay, binary is a 1010 1001 10, so that's we call the binary activation signal. And then connected by directed, okay, weighted parts. Okay, mana every input will be multiplied with weights, okay, and then the connection part accessory if the weight is positive, and inhibitory if otherwise that means the weight will be negative. Okay, will be negative, so this one will be inhibitory, right? So the all accessory connection is into the particular neuron have the same weight lah. That means, for example, if we have 46, okay, 46 input, that means all the weight will be until 46 will be 1 or will be 0. Okay, so for simplicity normally we can set, okay, we can set our weight, all the weight will be 0, okay, or will be randoms or will be 1 but all the weight will be same okay, will be same. Okay, neuron will be fired, okay, when inputs to the neuron is greater than threshold. This similar like the example that I shown before this. All right, so the output, okay, depends on the input lah. So if greater or equal with threshold, okay, is our threshold. Okay, so that mentioned to you, if equals or greater than threshold, so our output will be 1 lah. Okay, or fire. Okay, or fire. 1 will be fire lah. Okay, or less than threshold, so y equals to 0. Okay. All right, so it take one time step for the signal pass over the connection link lah. So no learning, okay, that I mentioned to you. So no, for example, this is introduced by McCulloch. So x1, x2, we call the bias lah, for example. Okay, the x, this is y. All right, so every weight here, so this one we have weight, and then we have weight. So no adaptation, no adaptation of the weight lah. Okay, so the neural network is implemented in the hardware. All right, so such as a relay and resistor lah. Okay, this is some application of using the McCulloch-Pitts lah. Okay, but this one is the old version of relay lah, not now not now. This is the old version of resistor and relay lah. Okay, so this is architecture of the McCulloch-Pitts. Okay, that you have to remember this one. So similar like I explained before this. Okay, so if this one if S, that means S is net input greater or equal than threshold, so automatically our Y, this one we call Y lah. Y is the 1. Okay, if less than threshold, Y equals to 0. Okay, that is the output the output lah that you have to set based on the threshold. Okay, so that mentioned to you, they will be same. First, we have to calculate the S. Okay, depends on some of the neural network, they have the bias. Okay, some they don't have the bias. Okay, but this is standard formula lah. Xi, Wi. Okay, that you have to remember. This one, S net input is equals to B plus summation of Xi, Wi lah. So if we have, for example, we have Xn here. So S1 multiplied by W11 plus X2 multiplied by W12 and until Sn multiplied by W1n. Okay, and then you get the S here. Okay, S got something. then compare then threshold lah. Okay, compare then threshold. So if greater or equal than threshold, so automatically our y equals to 1. Kalau if, for example, if the s less than 0, so y equals to 0. Okay. So maybe we go for simple example. Simple example. Alright. So you can see this one. This is we call the first iteration. First iteration. Alright. So this one we want to prove. Okay. This one we want to prove is it correct or not. For example, our y1 equals to 1. Alright. So x2 equals to 1. Okay. The first iteration. This one. The first iteration. Right. Okay. No bias here. And then our threshold. Okay. Threshold set to 2. Okay, set to 2. Okay, so the first step, calculate the S. Okay, so no bias. Okay, bias is you can write like this. Okay, SIWI. So no bias, 0 plus S1, W1. Okay, plus X2, W2. W2 is 1. Okay, so equals to 2. That means compare with threshold. So Y equals to 1. Okay, that's why here Y equals to 1. Okay. Next, we go for the next iteration. Okay, next iteration. That means our S1 will be 1, our X2 will be 0. Okay, but the weight will be maintained. That the McCulloch. So no adaptation of the weight. The weight will be maintained. Will be same. Okay, we go for example for second. This one for first. So we go for second. Okay, second. Okay, bias is no bias. That means 1 multiplied by 1. Okay, and so 1 0 multiplied by 1. Okay, so the answer S equals to 1. Compare with threshold, so Y equals to 0. Okay, that's why you get here. You get 0 here. So and then for the 3, similar like this one, you have to calculate the S. Okay, S. Okay, the iteration will be this one will be 0 and this one will be 1. Okay, this one will be 1. All right, so 0 multiplied by 1. Okay, so next is 1 multiplied by 1. Okay, so S equal to 1. Then compare with threshold. So threshold is 2. So this one less than threshold. Y equals to 0. Okay, that's why here we get the 0 here. And then last one. For the last one, you can see this one. So for next iteration, 0 0. X1 0. X2 will be 0. Okay, so S equals to 0 plus 0 multiplied by 1 plus 0 multiplied by 1. Okay, so S equals to 0. So compare with threshold, Y equals to 0. Okay, that's why you get here 0. So there is some example for to solve the n function. This one like similar like n function. And then for next we try, you can try this one for the O function. To O function. So same, we have the threshold equals to 2. Okay, so the first step we have to iteration 1. Okay, this one will be 1 and this one will be 1. Okay, so first you have to calculate the S lah. S for sequence number 1. This one for iteration number 1. Okay, no bias, so straightforward. 1 multiplied by 2. Okay, this one weight will be set by 2 plus 1 multiplied by 2. Okay, because of weight is 2. And then will be 4. Okay, so that's why Y equals to 1. Okay, Y equal to 1 because greater than threshold. Okay, S greater than threshold, so Y equals to 1. Okay, this is for number 1, iteration number 1. You can see for iteration number 2, S. Okay, 1 multiplied by 2 plus 0 multiplied by 2. Okay, so the answer will be 2. And then compare with threshold, so Y equals to 1 because of threshold is 2. And this means S greater or equal with threshold, so automatically Y equal to 1. That's why you can get here Y equal to 1. Okay. Alright, so for the next same. So for the next iteration, okay, you can see next iteration will be same. The width, okay, here will be maintained. Will be maintained at 2. Okay. For example, if you set the initial is 0, that means all the iteration will be weight equal to 0. Okay. For example, you set as the 1, weight is equal to 1. So this one weight equal to 1. So for the next iteration, also the weight equals to 1. Okay. That is the McCulloch. No adaptation of the weights. Okay. All right. So next, you can see this one, we go for the herbs. Herb, they adapt the weight, okay, that adapt the weight lah. That's why we call the first learning algorithm lah. The learning algorithm, that means the this will be adapt the weight lah. Okay, so the Herbs neural networks, okay, developed by Donald Herbs, okay, is the psychologist in 1949 lah. Okay, alright, so actually he developed the first learning algorithm for the neural network where the weight is added iteratively lah. Okay, for example, that I mentioned to you, so 0, 0, first iteration, second 0, for example, 1, 1, 1, 0, 1, for example. This is first iteration, second iteration, third and fourth. Okay, so initial weight is the, for example, initial weight is the 1. Okay, it's 1, for example, weight 2 is 1. Okay, but for the second iteration, our weight here will be changed. Okay, this one will be changed and this one will be changed. Okay, and this one will be changed. Okay, depends on this part. Okay, this one depends on this one. Okay, and third iteration, the weight will be changed depends on second iteration, and similar like fourth iteration will be changed depends on the third iteration. Okay, so that we call the Herbs neural network. So they introduced the learning algorithm. That means the weight will be added iteratively lah. That means will be added on the iteration. Alright. So on the McCulloch, so no adaptation of weight. McCulloch is no adaptation of weight, but for the Herb, they have the adaptation of the weight for every iteration lah. If we have four iteration, that means every iteration they have the adaptation of the weight. Alright. For example, if we have 8 iteration, that means every iteration they have the adaptation of the weight lah. Okay, so they have some formula. After that, I will show this formula of adaptation to adaptation for the weights. Right. So you can see this one. The Herbs, okay, can be used to with the pattern that are represented either binary or bipolar vector lah. Okay, so you can see the limitation of these Herbs. Cannot apply, okay, cannot apply on in the real world application lah. All right, so that's why just Herbs just introduce the learning algorithm, but they cannot use for apply on the real world lah. But will be the first learning algorithm, okay, will be introduced by Herbs, and then the next will be introduced for the Perceptron by Rosenblatt. Okay. Okay, so this is a learning Herbs algorithm. All right, so they have the step lah. Okay, so for example, you can see this one. So the first you have to set up if you want to model. Okay, if you want to design your neural network model, so you have to set up lah. Set up the neural network model. So you have to determine the inputs, outputs, how many inputs, how many output. So this is neural network have the bias or not, and also there's a threshold. Okay, so for simplicity, you can see this one. Initialize all bias. Okay, sorry, all weights. Okay, initialize all weight. That means for simplicity, normally we set weight as 0 or 1 Okay, for simplicity. Okay, you can set as the 0 or 1 for the simplicity. Initialize all the weight if not given Okay, if not given, so just automatically you set to the 0 or set to the 1 But for example, like our exercise, okay, our example, normally we give the weight we give the weights, and we already set the weights okay, and also set the bias. Okay, for this one, if you want to design, okay, so you can set initialize all the weight equals to 1 or equal to 0. Okay, next step, you have to for each input training vector and the target output vector So just, okay, this is input, and then another part you can put as the target output pair output pair. All right, that is the how to sequence, how to write the Herbs learning and then step number 2 is the set activation for input units. Okay, that's why you can set as this one x1. Okay, normally they put as the u1, so you can change to x1, right? And then step 3, you can set activation function. Right, so y equals to t. Okay, y equals to t. Okay, right, so the next y equal to t lah. This is we call the activation for the output unit. Okay, so this is formula, all right, that you have to adapt the weights. All right, so for final or for the test, okay, normally we given the formula, no need to memorize, okay, but you have to know lah how to use this formula. Okay, so this is formula to adapt the weight and also adapt the bias. Okay, so the weight new, okay, equals to weight old, okay, plus xi multiplied by y. Okay, that is formula lah. And then for adjust the bias, b new, okay, new equals to b old plus y. Okay, that is formula that you have to know lah, for the herbs. Okay, this is that I mentioned to you for every iteration. So the weight and bias will be adapt. Okay, will be adapt using this formula lah, using this formula. Okay, so this is some simplicity of the adjust the weight lah. Okay, the new will be same. Actually, this one will be same lah. Okay. Right, so this one, for example, if you want to adapt the weight one, I just give one example, the weight one new. Okay, this one will be weight one old. Okay, plus x1. This one will be x1. Okay, this one will be y. Okay, y1 lah. Okay, y1. Right, so this one will be y1. For example, if we have the x2, okay, sorry, w2, similar like this, w2 new, okay, equals to w2 old plus x2, x2 y2, okay, and then so on lah. If we have 10, okay, weight 10 new equals to weight 10 old plus x10 y10 lah. Okay, that is how the weight will be added for every iteration lah. Okay, so maybe we go for some example here. Some example. All right, so okay, first you can see this one. So first we have to convert this one to the x1 lah. X1, this one x1, and then y equals to t. Okay, right, so maybe I show some example here. So y one, first iteration, okay, our t will be 1, and then automatically y equal to t, this is 1 lah. All right, okay, you can see this one. This is first iteration, and then this is initial lah. Okay, we can put this one. You can put here lah, 0, 0, 1. The bias is 0, 1 lah. All right, so this one we have the new weight. Okay, the new weight and new bias. Okay, so first you have to calculate the weight 1 lah. Okay, weight 1 new. Okay, with all 1 is a 0 plus x1 1. Okay, 1 here, and y goes to 1. Okay, that's why our will be 1. So this one will be changed. So you can see this one will be changed to 1. We change to the 1. Okay, next w2 new, sorry, new. Okay, w2 old, okay, is a 0, and then plus x2 is the 1. Okay, y equals to 1 lah. Alright, so it will be 1. So this one will be changed. Second, you can see this one, the first iteration, the weight will be changed to 1. So this one cancel out. We just move to this one, to the initial lah. To the initial. Okay, and then for the bias, okay, formula for the bias you have to remember lah. B old. Okay, this is B new lah. B new plus y. Okay, so B old equal to 1. Okay, our y equals to 1. That's why B new equals to 2. Okay, this one change to 2. Right? Okay. Right, so you can see this one. The initial weight is the 0, 0, 1, and then the first iteration. So you can see how the weight will be added. From 0 to 1. So 0 to 1, you can see this one. From 0 to 1, and bias from 1 to 2. Right? Using this formula lah. Using this formula for adapt the weight, and this one for adapt the bias. You can see this one. Alright, that is the formula to adapt the weight and bias. Okay, so maybe we can try another iteration. So this is first iteration, second iteration. Alright, so we change to the x ni, this one 1 0. So our t is 1, automatically y equal to t, so t y equal to 1 lah. And then we have to adapt the weights. Okay, adapt the weight 1 weight 1 new. Okay, this one part, on this part also the weight will be changed. Okay, will be changed. So the weight all will be 1 this one will be 1 here. So that's why this one refer to the previous, and second iteration will be refer to the first iteration. Okay, plus x1 1, and then y will be 1 lah. So automatically weight 1 will be 2. This one will be 2. Weight 1 new will be 2. Okay, so we go for the next weight new 2. Okay, all equal to 1 plus x1 x2 is the 0. Okay, this one is 0 0, x2 is 0 here, and then multiply by y. Okay, so will be 1. So second, you can see no adaptation of the weight but because of the input is 0 lah, so the weight will be maintained the weight will be maintained here. And then next we have to go for the bias lah. Okay, the bias. Okay, bias new. Alright. Okay, the bias all equals to 2 plus y equal to 1. Okay, so that means bias equals to 3. So the next iteration you can see the weight will be changed. So the weight 1 will be 2, the weight 2 will be 1, and then the bias will be 3. Okay, the value of this one and then next you can try lah. Next you can try for the third iteration and fourth iteration For example, I just go for the next iteration Okay, go for the third iteration. Okay, that means here 0 1 0 1, and then our target will be 1, and then y equal to 1 Okay, y equal to 1 I put here. So and then we have to edit the weight 1 Okay, weight 1 new. Okay, so weight 1 all is the 2 plus, okay, this is a 0, and then y equal to 1. Alright, so the weight will be 2. So next here, okay, here will be 2. Alright, so this one will be 2, and then next w2 new, w2 all 1 plus x2 1 multiplied by 1 y1, okay, equals to 2. So the here weight will be changed to 2 lah. And then last is the bias. Okay, the bias new all is the 3, okay, plus y equal to 1 here. Okay, so that's what bias equal to 4. Okay, that's why you can see so every iteration the weight will be adapt lah. The weight will be adapt. Okay, for every iteration lah. So next you can try for the weight is a 0. Okay, for input 1 and also for input 2 will be 0 lah. And then you can see the changes of the weight 1, weight 2, and also the bias. Okay, so this is some example of the herbs. Okay. Alright, so next I will go for the perceptron. Alright, then we can stop lah. Okay, for our lecture for today. So just we cover for the perceptron. Okay, until the perceptron. Alright, so the perceptron, okay, that I mentioned to you, the perceptron is developed by Frank Rosenblatt in 1958. Okay, so its learning rule is superior than the Herb's learning rules. Alright, it's more better lah. That means the learning rule for perceptron is more better than Herb's learning rule lah. Okay, that has been proven by Rosenblatt that the weight can be converged into the particular application lah. Right, so however the perceptron, okay, you can see this one the disadvantage of perceptron cannot work for non-linear. Okay, the perceptron works for the linear application for the linear application that proven by Minsky and Peppert in 1969 Okay, the limitation of the perceptron. Normally the perceptron work for the linear application or linear system. Right, and then the artificial function used is the binary step function with an arbitrary but fixed threshold. So the threshold will be fixed and then the weight are adjusted by the perceptron learning rule. So this is formula Okay, this is a Okay, so this is a formula. Okay, formula to adapt the the weight. So you can see this one. So this formula will be also similar, but they have the different here lah. Okay, different here. Alright, so the weight nu equals to weight old plus alpha. Okay, this we call the learning rate. Okay, alpha is the here with the learning rate, t is the target, and then multiply by si. Okay, si. So this one, so this is a formula for perceptron. Okay, this one for perceptron, and also the for the bias. Okay, for the bias, similar like this. Okay, bias new. Okay, bias old. Okay, plus alpha t. Okay, that is this formula to adapt the weight. Sorry, this one bias and this one for weights. Okay. Alright, so let's go for the perceptron algorithm. So this is a standard lah. You have to set up your neural networks that I mentioned to you. For simplicity, you can set the weight or bias. Okay, set to 0. Okay, you can set to 0, or you can set as a 1, or you can randomize lah. But mentioned to you, for simplicity, normally you can set as the 1 or as the 0 lah. Okay, or 0 or 1. Instead, you use randomize, better you set as the 0 or as the 1. Okay, but for the example, for the test, normally we're given the weight lah. Normally we will be given the weight will be given lah. Okay, but if you want to design using the MATLAB, okay, you can set all the weights to our bias to 0 or 1 lah. Okay, normally I set weight equals to 0. Okay, the bias equals to 1. Okay, for simplicity lah. And then also you can set the learning rate lah. Okay, the learning rate is from 0 to 1. Okay, from 0 to 1, and threshold you can set from 0 to 1 lah. Okay, the threshold you can set from 0 to 1. Okay, but for our class, okay, for exercise, normally this learning rate and threshold will be given. This threshold and learning rate will be given. That's why you can see for simplicity, alpha, this is the learning rate can be set as the 1. Okay, can set of 1 for simplicity lah. Okay, and then you can see for the step 2 and step 3 will be similar like herbs. Okay, just change from u to x lah. Okay, u to x. Okay, for example, we have u1. That means change to x1 lah. Alright, so on the perceptron on this part. Okay, step number 4. Okay, step number 4, you can see this one. Alright, so this is standard. Okay, we have to calculate. Okay, S equals to net input. Net input we have to calculate is the B plus summation of SIWI. Alright, after we get the S, okay, so we have to compare. Okay, this is the for perceptron. You can see this one. After you get the S, you have to compare. So this is comparison. Alright, so if S greater than threshold, okay, this means here our maybe I set threshold equals to 1. So 1. Okay, so that means, alright, so if S greater than 1, that means Y equals to 1. Okay, if S less or equal than threshold or greater than equal the negative threshold, Y equal to 0. Okay, if S less than negative threshold, so our Y equals to negative 1. Okay, that means similar like this lah. Okay, for example, we set as the threshold is the 1, so this is range lah. Okay, for example, so this is 0, this is 1, this is negative 1. So okay, so if S greater than 1, Y equals to 1. Y equal to 1 here. If S between, okay, between this one, between greater or less than threshold, equal than threshold, here this part, okay, from 1 to negative 1, okay, so Y equals to 0. If S less than negative 1, okay, then threshold, okay, negative threshold, so Y equals to negative 1. Okay, there is three input you have to 3 output you have to remember this one. So yes, you have to remember lah. Okay, depends on the threshold. So we set threshold as the 1. So that's why the range here will be 1. This one will be -1 lah. So if S greater not equal S greater than Y equals to 1 lah. Okay, but if S less than or equal with threshold 1 and greater than or equal to negative threshold, so Y equal to 0. Okay, this one from this part, okay, to this part lah. Okay, from this to this part and then if S less than negative threshold, for example S -2, so Y equals to -1 Y equal to -1. Okay, that is that we have to remember for the perceptron. Okay, they have the condition. Okay, they have the condition lah. So this, after you calculate the S, you have to refer the condition. What is the output for every condition lah. For example, after you calculate your S, okay, first iteration, so you get S greater than threshold. So automatically Y equals to 1, for example. Okay, if S between this one, so automatically we know this Y equals to 0. Okay, if less than negative threshold, Y equals to -1. Okay, so don't worry, this one for the test or for the final normally will be given. Okay, no need to memorize this one. Also will be given. Okay, so one will be given on the final lah. Okay, the formula for this one will be given lah. So no need to memorize but you have to know lah. So this one, okay, to get the output based on this condition lah. Alright, so then you can see this one so they have another condition. Okay, the next step number 5, you can see this one so if Y, after you get the Y here after here you can see this one after you get Y here, okay, you get this one Y, for example Y equals to 1 ke, Y equals to 0 or Y equals to, and then you have to compare with target. So you have to compare with target. This one normally target will be given lah. Normally target will be given, so you have to compare Y compare then target. If Y not equal with T, so we have to adapt the weight and adapt the bias. Okay, but if Y equal to T, no need to adapt, just take the previous weight. Okay, initial the previous weight. Okay, just take the previous weight. For example, the previous is 0, that means the new also 0. This one, the condition Y equals to T, that you have to remember lah. Alright, this one but this one also formula also will be given on the midterms, on final so no need to memorize lah, but you have to know so you have to compare after you get the S, okay, net input, so and then compare to get the Y. Okay, next step, get the Y, and then for example Y, what is the Y, and then compare with T, then if Y equal T, so no need to adapt. Okay, just take the previous weights, but Y not equal with T, so you have to adapt. So this is another condition this is another condition that you have to remember lah. Okay, the first condition we have to get the Y, okay, based on the condition, and then second we have to compare with T. Then if Y not equal with T, we have to adapt the weight, but if Y equal with T, no need to adapt lah. Okay, that is the step number 5. Okay, then you can see step number 5 will be if no weight change in the step 2, okay, so you can stop okay, you can stop the iteration lah. So otherwise you can continue until you certify the after certify the result okay, so let's go for the some example here. All right, okay. Right, so you can see this one we go step by step. Okay, maybe we can draw the okay, I just go for the first iteration we go for the iteration. Okay, first you have to calculate dimension here. The first step you have to remember, calculate the S. All right, so okay, bias give it 1 here okay, by first I write the formula here S B plus submission of XI WI so this one is the standard. Okay, the first iteration what B. All right, S1 81. Okay, weight 1. Okay, weight here okay, weight will be negative 0.5. all right, plus okay, X2 -1, weight negative 0.5. okay, plus X3 -1, and then 0.5, negative 0.5. Okay, so calculate the S. Okay, so this one 1 plus 0.5 plus 0.5 plus 0.5. Okay, this one negative, so we cancel out, will be positive lah. So the answer will be 2. Okay, 2. So S, then compare, second step you have to compare with threshold. Okay, compare with threshold. So our threshold is the 0.1. So that means greater lah, greater. So automatically second step you have to compare with threshold. Okay, compare with threshold. So our threshold is 0.1. Okay, so automatically y equals to 1. Okay, y equals to 1. So and then next step number 3, you have to compare with targets. Okay, so our target here negative 1. So y equals to 1. So you can see this one negative 1. Okay, so y not equal with t. Okay, y not equals, y is 1, t is negative 1. So the next step we have to adapt. Okay, we have to adapt the weights and the bias using the formula lah. Okay, so this is formula formula for example weight new 1 new. Okay, weight 1 whole plus alpha target x1. Okay, all right, so the new weight is the negative 0.5 plus, okay, alpha given here 0.25. Okay, target is the negative 1, and then x1 will be negative 1. Okay, so this one will be the answer will be negative, okay, positive, so negative 0.25. Okay, that is for weight 1. So you have to this one for weight this one. Okay, for weight here. So next you have to adapt for this one for x2, weight x2 lah. So I put here another one here weight new 2. Okay, weight new old, just skip formula, so straightforward solve. Okay, similar, the old is the negative 0.5 plus 0.25 is the alpha. Okay, target is the same, negative 1, and our is a negative 1, similar. This one will be x, this one for second is the x2, this one will be x2, and then also x2 will be same like x1. That's why here will be similar like x1 lah. Okay, the new will be 0.25. Okay, okay, next you can try lah. So I just skip this one for x3. You can try this one. Okay, so I just go for the bias lah. I just go for the bias. Okay, okay, for the bias new. Okay, the bias old multiplied by alpha y. Okay, sorry, alpha t. Okay, alpha t, alpha target lah. So the b old is the 1. Okay, plus alpha 0.25, target is the negative 1 lah. Okay, so we can get, okay, this is a negative. Okay, so 0.75. Okay, this is the new. Okay, this is the b new lah, b new, bias new right. So next, okay, you can see this is you have to calculate the x3 lah, also the x3. Next you have to calculate the second iteration. The second iteration, make sure first similar like the first step. First we have to calculate the s. Okay, this one please make sure. So the weight here already changed. Okay, this one already changed, this one already changed, and also the weight 3 also already changed because the previous this one. Okay, that's why after you calculate this one, okay, make sure the b also will be new one lah. So this one will be new one. All right, so that is some mistake from the previous. So for second iteration, make sure you adapt. Okay, you just follow the previous value already adapt lah. For example, like bias, the formula will be same. Is s equals to b plus summation of xi wi. Okay, but the bias here will already change. Okay, already changed to 0.75. Okay, that's why here will be 0.75. I'll just show some example here for x, for second iteration, plus, okay, x1, okay, x1 is -1. Okay, weight 1 will be changed to this one, negative 0.25. Okay, plus x2 -1. All right, weight will be changed to 0.25, for example. And then weight 3, okay, x3 will be 1, and weight 3 maybe I assume as negative 0.25. Okay, all right, and then calculate the s. So what is the s? Okay, that will be similar, but the value will be changed lah, depends on the first iteration. Okay, because of the first iteration, the weight will have to adapt. Okay, if not adapt, so just follow the previous lah. Follow the previous lab, follow the previous weight and bias. Okay, so you can get what is the s, and then compare condition to get the y. Okay, second get the y. After get the y, then you have to compare with target. So this one target, for second iteration, our target is 1. Okay, what is the y? So for example, you get y equal to 1, y equal to 1. So y equals to t. For example, for second iteration, y equal to t. So no need to adapt, just take the previous. That means for second iteration, the weight will be maintained. So the weight will be, weight 1 will be negative 0.25, weight also 0.25, weight 3 also negative 0.25, and bias 0.75. Okay, because of y equals to t. All right, this is another condition. Okay, you can see this one. All right, so this one I will explain again. The first step. Okay, so this one, the first step you have to calculate. This is first iteration. Okay, the first iteration. All right, so you get 2.5. Okay, for example, I got 2.5, and then compare with threshold. So that's why y equals to 1, and then compare with target. So y, this one you can change. Y not equal with t. All right. So that's why we have to adapt the weight lah. So that's why the answer will be negative 0.25, negative 0.25, negative 0.25, and this one 0.75. Okay, there's the weight new 1, 2, 3, and also the bias. Okay, and then you can see on the second iteration. Second iteration, you can see already changed here. Okay, so you calculate. So this one that I mentioned to you, you can see this one. So the weight and the bias here already changed. Okay, depends on the weight number 1, because the weight number 1 already changed, will be adapt. Okay, will be adapt. And then the second iteration, you have to use the new lah. Okay, you have to use the new. Okay, you can see this one. So the bias is the 0.75. Okay, and then at the end you can get the s equal to 1, and then y equal to 1 and then compare with target. So y equals to t. Okay, this one no need to adapt. Okay, that's why the old will be same new lah. New will be same old. So this is for second iteration, no need to adapt lah. Just take the previous. Okay, take the previous lah. Okay, this is for second iteration. I just go for another iteration for iteration 3. Okay, you can see this one. Alright. So iteration 3, x1 -1, 1 -1, and t is 1 lah. So you can see first, you have to calculate this. You have to remember this one. The first step, calculate the s, net inputs. Okay, calculate, and then you get, I think will be similar lah, because the value is not changed. Okay, the value, but the difference is there on this one, on the inputs. Okay, the weight and bias will be same, but the weight will be different lah. And then total, they get the 1, and then compare with y, get 1, and then target is 1. So y equals to 3, so no need to adapt. So next, you can see in the third iteration also no need to adapt. Okay, no need to adapt because of y equal to t. So no need to adapt lah. So you can proceed for the next iteration. Okay, I will show some iteration. So next iteration, you can see this one. Okay, so you can see this one. Also, for iteration is y equal to t. So also no need to adapt. And then you have to go for the next. Okay, next iteration. All right. Also, we get y equal to t. So no need to adapt. Will be just take the previous. Okay. This is the previous weight. Okay, from this one. From previous this one. okay, from iteration 4. Okay, that mentioned to you. So this one, iteration 4 will be referred to the iteration 3, and iteration 3 will be referred to iteration 2, and so on lah. Okay, so this one for the 6 iteration will be referred for the 5 iteration lah. Okay, similar like this. Okay, and then you can see, so until 7 iteration, so no adaptation weight lah. So no adaptation weight and bias, so we follow the previous. Okay. Okay, but for the last iteration, okay, you can see the last iteration is x1, x2 1, x3 1, target is 1. So you get here, okay, 0, s is 0. So and then automatically is our threshold, and this is in the range. That's why we get y equals to 0. And then y equal to 0 compare with t. So t is 1, so not same lah. Y equals not same with t. Okay, that means y not equal with target, so we have to adapt lah. Okay, so that's using the all weight. Okay, and then multiply by alpha. Okay, target and x1 lah. Okay, and then so the weight will be, the new weight will be 0. Okay, 0 0 1. Okay, that's all for iteration until iteration 8. Okay, this one, okay, the first iteration, okay, we call it iteration until iteration number 8. This one, the loop we call one epoch. Okay, one epoch. If you want to implement 2 epoch or 3 epoch, so this one, the sequence of this iteration will be repeat again. Okay, will be repeat again. So iteration 1 until iteration 8. Okay, so this is we call the second epoch. Okay, we repeat again. Okay, 1 to 8. So this one will be third, and so on. Okay, so you can see this one. So this is our first epoch. You can see. And then for second epoch, they use this one. For the previous, this one you can see. Okay, you can see this one. So the previous, this one they refer to this one. Okay, not refer to the initial. This one is wrong. Okay, if you refer to initial one, is wrong. This is initial actually. This is initial, but after second epoch, okay, this is new weight. Okay, 001. So for the next epoch, you have to follow the latest one. Okay, that's why you have to refer to this one. That's why you have to refer 0001. So that's why the initial for the second epoch will be 0001. Okay. And then you can see until will be no adaptation lah. Okay, just one adaptation on this part lah. Okay, for the third epoch, you can see around the third epoch. Okay, they use the same. You can see this one. They use from this one, this part. Okay, this one. This is third epoch. So they use the initial weight. Okay, from the second epoch. Okay, second epoch for the last iteration lah. Okay, this one also last iteration for iteration 8. For epoch number 2, right? Okay, so maybe we can try. Okay, before we end of our class, so maybe we can try this one. Okay, we can try this one. All right, so I will show some example here. Okay, so our x1 will be 1 first iteration. Okay, all right. All right, so initial, yeah, I will change. Okay, all the way will be -1. -1 initial I put here. -1, -1, and bias will be 1. All right. Okay, so alpha rate will be 0.5, and then threshold 0.2. Okay, the first we have to calculate the S. Okay, remember this one. The first step, calculate the S. Okay, S equals to, okay, bias is 1 plus S1 with -1. Okay, just follow with me. You can try at home. Just follow with me lah. So weight, okay, weight x2 input is 1. Weight 2 is -1 lah. All right. Okay, so okay, negative 2, -1 lah. Okay, so -1 -1, okay, -2, okay, -2 plus 1, okay, -1 So and then we get y lah. Second step, you have to get y. What is the y? Okay, so you have to remember this one. Our threshold will be Okay, this you can put as this one, y equals to 0, y equals to 1, y equals to -1. Okay, this one we set as the 0.2, 0.2, okay, negative. Okay, so you can see, so our will be here, our our s will be here, so automatically y equals to -1. Okay, y equal to -1 seconds, then you can compare with target. So sorry. Alright, so you can compare with target. So our target will be 1. So automatically y not equal with target. So we have to adapt lah. We have to adapt with 1. Okay, we have to adapt with 1, with 2, and also the bias using the formula. Okay, so maybe I just try one example lah. Okay, so with 1, I put here. With 1 new. Okay, with y all is the -1 plus alpha. Okay, alpha is the 0.5. Okay, and then target is 1, and then x1 is 1. Okay, this means weight will be 0.5. Okay, negative 0.5. Okay, so here, okay, this one we have to write lah. Okay, this one will be -1, y equals to -1, and then t equals to 1, and then weight negative 0.5. Okay, then second weight number 2, new. Okay, I think will be same, -1 plus, okay, 0.5, x1, x2 will be 1, and then target is 1. So also similar lah, negative. Okay, so this one will be negative 0.5. Okay, and then next is the bias lah. Okay, the bias. So the bias new. Okay, bias old will be 1 plus alpha 0.5. Okay, and then multiply by target. Target is 1 lah. Okay, so the answer will be 1.5. Okay, 1 plus 0.5. Okay, so the new bias will be 1.5. Okay, 1.5. Okay, this is for first iteration. Okay, the first iteration here. Okay, next we can go for the next iteration lah. You can see for next iteration. So I will put here. So we want -1. Okay, we have to calculate the S. Okay, the first step we have to calculate the S. It will be same like the first, but that mentioned to you. So the weight will be changed. Okay, the bias also changed. Okay, so 1.5 plus summation of S1, 1. Okay, weight 1 negative 0.5. Okay, plus x2 will be -1. Weight 2, okay, negative 0.5. Okay, okay, right. Then you can total out what is the S. Okay, for example, this one positive. Okay, this one positive. Okay, this one will be 1. Okay, will be 1.5 lah. Okay, will be safe. Okay, 1.5. Okay, because this one 0. Okay, positive. Okay, so negative. So that S equals to 1.5. Okay, 1.5. This one 1.5 for example. And then our Y, okay, so 1.5 here. Okay, the location here lah, 1.5. So Y equals to 1. Y equal to 1. Our target is the -1. Okay, so Y not equal with target. So we have to adapt the weights. Okay, so for second iteration, we have also to adapt the weight. Also adapt the weight and bias lah. Okay, because of next step you can see this one. Y not equal with target. So we have to adapt lah. The new one, new. Okay, old negative 0.5 plus, okay, alpha 0.5. Right, so this one will be maintained. Alpha will be maintained from the for every iteration. Okay, this one is a fixed. Okay, 0.5, and then multiply by target. This one, target is the -1. Okay, so and then multiply by x1. X1 is 1. Alright, so negative. Okay, that will be -1. So this one will be okay, right. So negative. Okay, so this one will be -1. Okay, weight number 1 change. Okay, from negative 0.5 to -1. Okay, and then for weight 2, new. Okay, so similar 0.5, okay, plus 0.5, okay, but the x2, okay, the target is the -1 and the input x is the -1, okay, -1, okay, negative, positive, okay, this one weight 2 will be 0. Okay, so the weight 2 will be 0, from negative 0.5 change to 0. Okay, then for the bias, okay, for the bias new, okay, bias all 1.5, okay, multiply by 0.5, okay, multiply by target. So our target is -1 lah. Okay, so will be 1, all right, will be 1. Okay, so next will be 1. Okay, this is, you can see, so this one, okay, will be refer, this one will be refer, this one will be refer to initial, all right, refer initial, and then this one will be referred to this one, this part, right? So for third iteration, similar lah, okay, just similar, just repeat again, okay, repeat again. First you have to calculate the S, get the Y, okay, based on the threshold, right? After get the Y and then compare with target, compare with T lah, compare with T. So if Y equal with T, so no need to adapt, okay? And then if Y not equal with T, so you have to adapt lah using the formula, okay? Using the formula, right? Similar like for iteration lah, okay? For iteration, okay? This one we call the 1A push, okay? This one 1A push lah, we call the 1A push. Right, so over the 1A push, okay, this one we call the 1A push, okay, until 4 iteration lah, okay, so that's why you have to solve until 4 iteration lah, until this one, but if the question need more than one, for example 2A push, okay, for example 2A push, so this is 1A push, so another one, after you get the 4 iteration, you have to put another one here for second A push, so will be 1, 1, repeat again, 1, 1, similar like this, 1, -1, -1, 1, and -1, 1, -1, -1, and then target will be same lah. 1, -1, -1, -1. But the bias, okay, the bias refer to the previous on the last, okay, on the last for the iteration number 4, okay. For the next approach, refer to the last iteration, okay, iteration number 4. Alright. So that's all for today. So until the perceptron, because of lots of mathematicals, okay, you can try. After this, I will try to give some example, right, on the groups. Okay, you can try at home. You can try. So this, okay, for McCulloch, herbs and perceptron, just simple mathematics. Okay, just simple mathematics lah. But you have to know lah how to do it, how to solve the perceptron. Okay, how to solve using the herbs and also using the McCulloch. Okay, straightforward using the formula. Okay, the mathematicals also similar. Okay, just simple, just like this one, for example, like this one is the digital 1001 or so, but this one we have the -1 lah. Okay, but simple mathematics just multiply. Okay, just multiply. Alright, so class, okay. Okay, class. Boleh,
Okay, Doctor.
Alright, so you can try lah. You can try. After that, I will give some example lah. Some example for the McCulloch. Okay, for example, herbs and also the perceptron. Okay, you can try. And then for this, next we go for the Adeline, Madeline, and also we go for the Fukushima lah. So you can see this one for McCulloch, herbs, and perceptron. Just focus only one neuron. Okay, only one neuron. Next, for the Madeline, okay, we focus, for example, we have 3, okay, that's why more complicated lah on the mathematical, okay, on the mathematical more complicated sikit lah, okay, because this one, you can see, only one neurons, okay, this one we cannot set as the networks, okay, still only one neuron, but for the Madeline, next, for the next class, we go for the Adeline, Madeline, and also the Fukushima lah, okay. And then the last chapter will be depth back propagation, okay. So next week, because of the I will some information. Because of next week we holiday on the Friday, so our class will be on the Wednesday morning lah. Maybe we start at 9. I just take 1 hour lah, 1 hour class. Can for next week and another next week. So we have to change our class lah, because the Friday we have a holiday. So we change to Wednesday morning. Maybe we start at 9 lah, 9. I try to finish on 1 hour. Maybe some of you have the class at 10. So I just try finish on the at 10 lah. So just because at the line is just a simple, similar like only 1 neuron, and then go to middle line. Middle line we have maybe more than one lah, more than 1 neuron. So next week class will be on the Wednesday morning. Wednesday morning. On maybe we start at 9 lah, at 9, and then try finish on the 10. Try finish at 10 lah. We inform them maybe if okay, we can start at 8:30, something like that lah, 8:30 until we finish in 10 lah. For next week and another next week, because of we have to holiday on the Christmas and the New Year lah. The New Year, right? So that's all for today class. For the lecture today. So is if you have any question, after this you have any question regarding your result for the test, so you can WhatsApp me lah. Because of I just marking on the paper, not on your paper, just marking on my paper lah. Because this online, I just marking based on the result. So that just I give the out of 10. For example, out of 10 lah. But the summary, the summary of the test one, I think so because of the online, I think average lah. So the average out of 40, so average is 34. 34 out of 40. That means it's lah. That's good lah, right? Because of the COVID. Before this, the previous is 36 out of 40, because of they have the class, the face-to-face class. But this one is online. The average is 34. That means for me it's very good lah. Congratulations to all. So for full marks, we have 3 students lah. We have 3 students get full marks lah. The 40 out of 40. Forgot the name. I think the got full mark. You can check you can check on the Teams. I think I remember the Crichton. Crichtons. Liu. Forget the name. They have the name. Crichton. Crichtons. Lai Ngit Xiu. Muhammad Akmal Shafi. Yazid. Got the full marks. I think the rest almost, because of some simple mistake. Question number 1, I think almost 98% got the correct answer. Only one student don't get the correct answer lah. Only one, it's lah. Question number 2 also but some of the mistake. For example, you just straightforward. I think just some of you don't use the calculator. For example, like 0.4 multiplied by 0.2. For example, just straightforward. Maybe some of you got the wrong answer. But just I think 90% correct lah for the question number 2. And most of you on the question number 3 lah. On the question number 3. So maybe after that I try to discuss the result, not the result, the solution. The solution for question number 3. I think only 50 student, only 50% student lah got the correct answer for the question number 3. That's why some of you missing on the mark on the question number 3 lah. And then question number 4, not bad. I think most of you get the answer. I think around 80% lah. 80% get the correct answer lah for the question number 4. The average is lah, 34 out of 40. That's all for summary for the test number 1. but it can improve for the next test for the cover on the neural networks. Okay. Also, the test for the neural network also straightforward, similar like this one. I just give the question, for example, like this one. So you have to solve lah using the McCulloch, okay, using the Perceptron, or using the Medellin and so on. Okay. All right. So that's all for today. Okay. So if you have any question regarding your test, okay, maybe you can ask me later lah. All right. So thank you very much. Okay. Assalamualaikum warahmatullahi wabarakatuh. And okay. Bye. Okay. Assalamualaikum.
Thank you, Doctor.
Okay. Welcome.